Imagine the entire universe, everything we see and know squeezed into a space smaller than an atom. It's almost impossible to fathom, yet this is where our story begins. That's the mind-boggling starting point of the Big Bang Theory, a concept that has revolutionized our understanding of the cosmos. This theory describes the birth of our universe, a moment when everything burst forth from an extremely hot, dense state billions of years ago. It was a time of unimaginable energy and potential. The Big Bang wasn't an explosion in the traditional sense. It was far more profound. It wasn't something happening in a pre-existing space. There was no before, in the way we understand time and space. Instead, it was the rapid expansion of space itself, stretching and growing at an unimaginable rate. Space itself was being created and expanded. This expansion continues to this day, like the expanding surface of a balloon being inflated. The universe is still growing, still evolving. As space expanded, the universe cooled, allowing matter to form and eventually evolve into the stars and galaxies we see today. This cooling process was crucial for the formation of complex structures. The Big Bang is a powerful idea. It provides a framework for understanding the vastness and complexity of the universe. It helps us understand the origins of everything around us, from the smallest particles to the largest structures in the cosmos. Every atom, every star, every galaxy traces its origins back to this singular event. The Big Bang Theory is supported by a wealth of scientific evidence. Observations of cosmic background radiation, the distribution of galaxies, and the abundance of light elements all point to this incredible beginning. It's not just a guess, it's the best explanation we have for how our universe came to be. Through the lens of the Big Bang, we can trace the history of the cosmos and our place within it. In the first moments after the Big Bang, the universe was an unimaginably extreme environment, a place of incredible density and heat. The temperature was trillions upon trillions of degrees, far hotter than the core of any star we know today. It was a searing inferno where conventional matter couldn't survive. Matter as we know it couldn't exist in this fiery cauldron. At these temperatures, atoms couldn't form, and even protons and neutrons were nowhere to be found. Instead, the universe was a chaotic soup of fundamental particles like quarks, electrons and other exotic forms of matter and energy, all swirling in a high-energy dance. Imagine a time when the four fundamental forces of nature, gravity, electromagnetism, the strong force and the weak force, were all unified into a single, indistinguishable force. This was a period of perfect symmetry. This era, known as the Planck epoch, remains shrouded in mystery. Our current understanding of physics breaks down, and we can only speculate about the true nature of the universe at this time. As the universe expanded, it began to cool. This cooling process was crucial for the next stages of cosmic evolution. This cooling allowed the fundamental forces to separate and for particles to combine into protons and neutrons, the building blocks of atoms. These particles would later form the nuclei of the first atoms. This early universe was a dynamic and rapidly changing place, setting the stage for the formation of everything we see around us today. From galaxies to stars, planets to life itself, all began in this primordial chaos. The Big Bang Theory wasn't the work of a single scientist. It emerged from the observations and calculations of many brilliant minds. In the 1920s, Russian physicist Alexander Friedmann and Belgian priest and astronomer Georges Lemaître independently used Einstein's theory of general relativity to propose an expanding universe. Lemaître, often called the father of the Big Bang, envisioned the universe starting from a primeval atom that expanded outward. Their ideas were initially met with skepticism. It was a time when most scientists believed in a static, unchanging universe. However, as new evidence emerged, the idea of an expanding universe and thus the Big Bang gained traction. The work of these pioneers laid the foundation for one of the most profound scientific revolutions in history. The Big Bang Theory isn't just a compelling story. It's supported by a wealth of observational evidence gathered over decades of research. One of the most compelling pieces of evidence is the cosmic microwave background radiation, or CMB, which serves as a snapshot of the infant universe. Discovered in 1964 by Arno Penzias and Robert Wilson, the CMB is a faint afterglow of the Big Bang. a whisper of light and energy that has been traveling through the universe for billions of years. This discovery was monumental, earning them the Nobel Prize in Physics. Another crucial piece of evidence comes from Edwin Hubble's observations in the 1920s, which revolutionized our understanding of the cosmos. Hubble discovered that galaxies are moving away from us, and the farther away they are, the faster they're receding. This phenomenon is known as the redshift. This observation, known as Hubble's law, implies that the universe is expanding, just as the Big Bang theory predicts. It was a groundbreaking realization that changed the course of astrophysics. The abundance of light elements in the universe, such as hydrogen and helium, also aligns with the predictions of the Big Bang model. These elements were formed in the first few minutes after the Big Bang during a period known as nucleosynthesis. These lines of evidence, along with others, have solidified the Big Bang as the prevailing scientific explanation for the origin and evolution of our universe. The theory continues to be refined as new data and technologies emerge, offering deeper insights into the grand beginning of everything we know. Section 5. The Expanding Universe, a Universe in Motion. The Big Bang theory tells us that our universe is not static, it's in constant motion. Imagine a loaf of raisin bread dough rising in the oven. As the dough expands, the raisins embedded within it move farther apart. Similarly, as the universe expands, the galaxies within it are moving away from each other. This expansion doesn't mean that our galaxy is the center of the universe. From any galaxy's perspective, all other galaxies appear to be moving away. The expansion of the universe is a mind-bending concept, but it's a fundamental aspect of the Big Bang model. Section 6. The Mystery of Dark Energy and Unknown Force. In the late 1990s, astronomers made a startling discovery. The expansion of the universe isn't slowing down as expected, it's accelerating. This unexpected acceleration is thought to be driven by a mysterious force called dark energy. Dark energy is a hypothetical form of energy that permeates all of space and exerts a negative pressure, causing the expansion of the universe to speed up. While we don't yet fully understand dark energy, its existence has profound implications for the fate of our universe. Will the expansion continue to accelerate forever, leading to a cold and lonely end, or will dark energy's influence change over time? These are some of the biggest unanswered questions in cosmology today. Section 7. The Big Bang's acceptance, from controversy to cornerstone. The Big Bang theory wasn't always widely accepted. In the decades following its initial proposal, it faced skepticism and debate within the scientific community. However, as evidence mounted in its favor, the Big Bang gradually gained acceptance. The discovery of the cosmic microwave background in 1964 was a turning point, providing strong support for the theory's predictions. Today, the Big Bang theory is considered one of the cornerstones of modern cosmology. It provides a framework for understanding the origin, evolution, and large-scale structure of the universe. While there are still unanswered questions, the Big Bang theory has revolutionized our understanding of the cosmos. Section 8. The Big Bang in simple terms, analogies for understanding. The concepts behind the Big Bang can be challenging to grasp, but analogies can help. Imagine a balloon with dots drawn on its surface. As you inflate the balloon, the dots move farther apart, just like galaxies in the expanding universe. Think of a firecracker exploding. The initial explosion represents the Big Bang, and the expanding cloud of smoke and debris represents the expanding universe. While these analogies have limitations, they offer a simplified way to visualize the basic principles of the Big Bang theory. Section 9. Unanswered questions and ongoing research. While the Big Bang theory has been incredibly successful in explaining many aspects of our universe, there are still unanswered questions. What happened before the Big Bang? What is the nature of dark energy? Are there other universes? These are just a few of the mysteries that continue to intrigue cosmologists. Scientists are constantly working to refine the Big Bang model and develop new theories that can shed light on these fundamental questions. The quest to understand the universe's origins and evolution is an ongoing journey of discovery. Section 10. The Big Bang Theory, our place in the cosmos. The Big Bang Theory provides us with a profound perspective on our place in the cosmos. It tells us that we are part of a vast and ancient universe, born from an extraordinary event billions of years ago. The atoms in our bodies were forged in the hearts of stars that lived and died long before our solar system formed. We are connected to the universe in a deep and fundamental way. The Big Bang Theory is a testament to the power of human curiosity and our ability to unravel the mysteries of the universe. As we continue to explore the cosmos, we can expect even more amazing discoveries that will deepen our understanding of our origins and our place in the grand scheme of things.